is waking up the world to the power of geography, the science of integration, and has the framework for creating a better future. And before I introduce to you the man who said those words, I just want to tell you a little bit about what Simpler Systems is doing and invite you to attend our thought leadership session tomorrow. My name's Carrie Collins, and I'm with Simpler Systems. And Simpler has been working with our clients for 20 years now. It's our 20-year anniversary. And what we do is we make it simpler for our clients to navigate their data. We really want you to have that power, that information, to help your constituents and to help you do your jobs in a very easy and fast manner. So tomorrow, we're going to be doing a session on implementation and how data apps can help that process. We've been working with Thomson Reuters, we've been working with several of their clients, and we've developed an approach that can help you be more efficient and reduce cost and save resources during any implementation. And we'd like to share that with you. It's tomorrow at 4 p.m., so please join us. So back to our main attraction this morning. It's very powerful. Framework for creating a better future. And when I started looking at the bio for this speaker today, and you see all of his professional organizations, honorary doctorates, awards, accomplishments, and Forbes magazine and Inc. magazine have both featured him and talked about how impressive it is that he started this company 30 years ago, 30 years, and has thrived with the technology company over that period of time. But then I started digging down a little bit deeper, and you see the work that he and his wife Laura have done, $165 million donation to the Nature Conservancy of very, very valuable land here in Central California on the coast. And you see what he's done with the kids. I had somebody last night tell me that she saw the kids camps that he does and nurturing the kids and bringing that next generation and helping them understand the world and geography and technology and how that all relates, how everything integrates. The people, his family, his business, the land, everything comes together. Framework for creating a better future. And so I have to tell you, after reading about it and after just meeting him, and what a pleasure it was to meet him, because he said, don't say anything about me, just say, here's Jack. Because he's very humble. But I had to tell you, because I have become a fan, and he is a very, very talented and wonderful human being who's really impacting the world around him. So I'd like to introduce to you from ESRI, Jack Dangermond.
Thanks very much, Carrie, and boy, how do you follow that? I mean, I'm supposed to be somebody smart and interesting. Anyway, thanks to Thomson Reuters for inviting me here, and thank you for coming up this morning and listening to what I have to say. I always like at the beginning of my talks to have people get to know each other. It makes me a little less nervous. So I'd like to have all of you stand up, turn around, meet one new person, and introduce yourself. Do that. How you doing?
David Besson. Nice to meet you, Jack.
I'm very happy to meet you. Yeah, it's neat. It's good. Great. Perfect. Thank you. That's wonderful. Thank you. Sit down. All right. Enough of that. Look, these sorts of meetings are really important, not so much from just the content that comes from the stage or critical speakers, but you guys forming relationships between each other, sharing what you do. So much of what we learn is from our colleagues. At least for me, I learn most from my closest friends. They tell me the truth, I can trust it, you know how it works. And these kinds of meetings are so important because you can listen to people's real experienced experience, not sort of artificial, non-experienced stuff. So I invite you to do exactly what I just had you do again and again and again through the day and through the week. When the people from Thomson Reuters asked if I would talk, it took me a while to sort of figure out what I should really share with you. And what I decided is to really share core GIS and mapping, what's going on there, and then how it relates to land information systems, your business, all aspects of it. And so these are going to be a series of slides. I'll go through them relatively quickly, but they'll bring forth what's happening in technology itself, and more specifically, what's happening in geospatial technology, and then more specifically, how does that relate to the kind of workflows that you do. And also, my good friends have suggested that your work is some of the most important work going on in America. I mean, land information is the foundation for our civil society. It's how we organize ownership and rights and public rights to property ownership. And being able to get that right is foundational to virtually everything else. Taxation, how we run our governments, how we run our society ultimately. So it's a pleasure to address you and share with you some of my work. Contextually, when I was a kid, I learned about geography. And it's been with me my whole life, a kind of science of our world, a kind of science of everything, a science of all the other sciences. And today we live in a complex world, wouldn't you agree? I mean, we've got people going to the right, going to the left, political debate. We have issues of climate change and social conflict, loss of biodiversity, all the things that we read about every day, and it's challenging. So we live in this complex world, and it's rapidly changing. Some would say accelerating. The change is accelerating. So I keep going back to this science that I love, geography, the foundation of virtually everything human, at least foundation for understanding everything human, and foundation for understanding everything in the natural world. And one does that with maps and overlays of geographic knowledge. And a big one is land information. And the changes that are occurring in our world, these issues that I talked about, are accelerating and challenging, some would say even challenging our future existence. I'm not so radical, but I do understand why they say it. The kind of arrows going in the wrong direction with respect to climate change and loss of biodiversity and loss of the sort of sustainable infrastructure that we live in. And land information and getting that right is so fundamentally important to being able to address these challenges. And geography, this science, I think, is foundational to that. Well, my whole life has been in this field called GIS. I got into it a little over 50 years ago in university, and that concept and automated mapping have been kind of what I've worked on during my whole career. And I would suggest to you that since you are the purveyors of a major piece of this infrastructure, that it's never been more important. It's almost essential infrastructure in government and in our society. It's never been so important to be able to know what is where and who has responsibility for it. It's helping, as it goes digital, it's helping us understand just about everything. And not everybody understands, and not everybody believes in science and the foundation for this, but it's now in digital form becoming essential for running institutions of many types. So let's start with this simple question. What is a GIS? What is a geographic information system? And many of you run all kinds of information systems, but for some of you, you don't think of automated mapping as an information system, but it is. A GIS is a system for managing and sharing and applying geographic knowledge. And it starts with data collection and updating of the data. Increasingly now it has real-time information, things like traffic movements or other IoT feeding living maps, and is enriched by remote sensing and imagery. And out the other side of these knowledge information systems are the ability to make maps or visualize them or do analytics, prediction, monitoring change over time, valuation change or whatever, and then being able to do planning and decision making, your colleagues in land use planning organizations, and now increasingly through maps, citizen engagement. Well, another way to look at GIS is that it's a framework and a process where we organize geographic knowledge of all types. We measure these layers, we analyze them, we do analytics with them, make predictions, and then we make decisions on them. Here's where your work particularly feeds other people's work in planning and engineering and the private sector's work to make decisions and then finally action them. Do you like this chart? I mean, I love this chart because it sort of shows a science process, a science-based process for creating information to create a better world, you might say. Bringing all the knowledge that we have into the mainstream for people to make decisions with. Now, this is going on in hundreds of thousands of organizations. It's not well known, but these are a few examples. In land information, people are using it not simply to maintain the system of record about tax lots, but they're associating with it attribute information, looking at land use, age of construction. They're doing 3D work in appraisals. They're doing collection with little devices to update CAMA data. They're looking at pictures to be able to communicate what's going on, like these property prices that are present, and on and on and on. These are just a few examples, in some cases, of your work and some cases of others. It's also being used to manage natural resources in mining, in forestry. It's helping oil companies know where to drill to be successful using AI tools. It's helping farmers know what to plant where by overlaying your kinds of information with other kinds of information to make decisions. These examples show your colleagues in urban planning and land use planning, creating new master plans, or doing urban redevelopment, like the example in South Korea, looking at designing 3D city models, provide clues about what's going on. And this is a basis for so much of what you do, seeing it. And these digital twins are allowing us to understand things in whole new ways. Without driving around and knowing a neighborhood, we can get a glimpse of it and see it. Now, your colleagues also in the engineering field are likewise employing these tools to do engineering design and also manage their field, manage their field workers, for example, mosquito inspection or valve exercising or work order analytics. I like this little red map showing vertical displacement in the sidewalks up here in South Dakota. It gets cold up there. I was just talking with a guy from Minnesota a few minutes ago. It gets 30, 40, 50 below zero up there. Well, they're able to predict things and predict things like engineering things. Your colleagues in buildings and facility management are seeing cities in whole new ways, taking smart geography into the building. And this has implications for things like 3D appraisals or on and on. in the private sector, it seems like geography has come alive. People are saying, I want to get the geographic advantage, locate my store in the right place. People like Walmart's and Walgreens and Harley-Davidson and Starbucks and McDonald's, they're all using geography, and in many cases, the very information that you folks here in the room build to be able to make better decisions. And preparing for disasters. I mean, you saw the last weekend the kind of thing that was going on with Florence. Hurricane response, doing damage assessment, but also in wildfire here in California is a big deal. Tracking the fire in real time, providing situation awareness. These are all critical issues that are confronting all of us. Now, in this field of digital geography, people are starting to say, I want to make this available to everyone, and they're doing it through what's called portals. Open data portals for sharing raw data, but increasingly citizen engagement portals for sharing and engaging citizens, that is G to C, government to citizen interactions around initiatives. I'll come back to that more in a few minutes. Well, let's go a little bit deeper on what is a GIS. GIS is a kind of information system, geographic information system. It's all about the geographic stuff. It's also what is referred to as an enterprise information system. And it consists of three parts. One part is the system of record keeping. In your case, for example, land information records, transactional updating the land parcel and attributes about it. It's also a system of insights or analytics. I can overlay land records, look at patterns through time, and create an understanding using advanced spatial analytics and AI tools. More about that in a minute. And third, it's a system of engagement. I don't know if you know what a system of engagement is. Social media is engaging all of us. We have our name associated with it. We share in Facebook. GIS is a system of engagement in the sense that it communicates to everybody through maps. People get engaged, and increasingly through user identities, citizens and also workers within organizations are getting engaged, giving them privileges about what information they can look at or not. So it's actually three systems in one. And it uses location, the heart of geography, to be able to unify these three different domains. Just imagine our systems of record are available to citizens to inquire and do analytics, or businesses to do G to B, and also for creating insights for our analysts in various ways. So the value of GIS is expanding. Traditionally, GIS has been for the specialist, the guys in the back office. And this science of where, as I like to refer to it, is certainly maturing in that GIS domain. But another domain is opening up, which is the domain of simple mapping and simple location intelligence. This is not for the sort of Poindexter. It's for mere mortals to be able to interact and work with maps and get insights from it. This field is advancing, and it's advancing sort of at the same rate of the rest of technology, and that's challenging to all of us to stay current, stay up. In part, it's advancing because there's lots of new kinds of data, remote sensing data or real-time IoT data, living maps, not static geology maps. And that's coming in from crowdsourcing, from remote sensing, from drones, and so on. It's also exponentially growing because of the technology evolution that we see with computing, faster machines and different architectures, distributed computing, cloud computing, microservices, and more recently, AI and machine learning within those cloud environments. And then there's the world of innovation in the geospatial area, spatial, temporal, algorithms that can allow us to look through time, 3D visualization tools, animation, augmented reality, and lots of things I will talk about for a few minutes. Out of these forces is coming a new generation of GIS. So I have a real problem. I started ESRI 50 years ago, not 30 years ago. So I'm even older than you think. I've been innovating tools. My colleagues have been innovating tools and releases of software. Now for 40 years, we've been releasing different products. And I meet a lot of people, and they'll say, Jack, I used your software in college 80 years ago, or not 80, but 30 years ago or 20 years ago. And I think, oh, that's really interesting. But the software was very different in those days. We ran on mainframes or mini computers, or then later workstations, or later then PCs, and then later client-server architecture. I'm, by the way, going through the whole history of computing. Client-server computing, and then server-based web services, and then now the web and cloud. And so what's occurring, like in the last couple of years, is a whole new generation of GIS is emerging, and it's based on web services. We call it a web GIS. And this is a modern architecture. It uses services, not client-server data. It's like a dial tone of data, a dial tone of maps. You dial in and you get a parcel map or a soil map. And you don't directly connect to the data, you connect to a service. And this architecture means that I can have data all over the world served to me dynamically over the web. And I can mash it up, I can overlay it from distributed sources. That means my land record information can be enriched, that's a technical term, enriched with demographic data or soil data or weather data or the hurricane data dynamically from a distributed server. Isn't that cool? Let's think for a moment what that means. Instead of putting it all in one big data bank that I run, I can keep my own data in that data bank, but I can read in these other services to enrich my own data. I can enrich a parcel with soil values, or I can enrich a parcel with surrounding demographics. What's within 5 miles of this parcel? It's a gold mine for assessment. So this is evolving very quickly, and it means cloud-based services can be accessible to me, to individuals, to teams, to whole organizations, and even the act of serving my data, I can serve it out as web maps now for citizens to get involved. The other dimension on this system architecture is that I can share and collaborate dynamically from these different dial tones of information. So what makes this so compelling? It's, by the way, just growing like crazy. What makes it so compelling is a few simple concepts, and I'll cover these in the next 10 or 15 minutes. One of them is web maps. Web maps are not like a Google map. They're an intelligent technical specification that allows me to mash things up technically. And then apps and lots of online content, so I don't have to own all the content. Open data, new analytics, services-based analytics, and that's all fueled, this environment is all fueled by data that you folks create and maintain. Web maps, let's start with this. Web maps are a new kind of language that's occurring. And web maps, like I said, is a technical specification. So I can create a web map on my device. I can share it with my colleagues. They can overlay my map with other people's maps, kind of like citizen, crowdsourcing, and even make those my maps available to a community in real time. That is like a language. I mean, people tell me that cuneiform is going away. Can you believe that? Kids aren't writing anymore. They're only texting. Just imagine that. So as text becomes a second-tier language, pictures, graphics, and particularly geographics are skyrocketing. On our little website, we make over 1 billion maps a day. And we're just beginning. Okay, this is not Facebook or anything, but it's gradually taken off. Billion is billion here, billion there, adds up. So this is going to be a way of the future. My thought is that maps will become a kind of language, much like we have numbers and text and music and other languages that we work with. This language is collaborative, and these web maps feed apps, so maps and apps. These are apps for storytelling, apps for dashboards, like what's going on in real time, 3D building apps, field apps. So just imagine that every field worker now is not simply looking at a Google map, but looking at all the maps that they really care about. And in addition, location analytics, or location intelligence, as it's sometimes referred to, is helping us understand distributed data at scale. Now, historically, this kind of spatial analytics was not for the faint-hearted. You needed to have, a GIS degree or really understand geography. But a whole new generation of web apps, similar to Tableau, if you know Tableau, business intelligence apps, has emerged, which allows us to drag and drop and explore data rather than hardwire a model and then understand. I can do exploratory work leveraging the power of analytics over the web. And these are just a few examples. I'll go deeper in this in a moment. So I'm talking about WebGIS, and I'm talking about and suggesting that it's not any longer about sequentially automating work. Many of you have already done that. Very popular in the 70s, 80s, 90s, and in the last 15 years. The next big step is what some people loosely call transformation. This is about taking our digital automation work and connecting it in through the web and web services so that it is a piece of a broader context information system, using location to connect different distributed information systems, systems of record or systems of analytics, simultaneously. So that simultaneously we're looking at all the work and fusing it to create new sorts of information. Organizations that digitally are responsive to the real-time changes that are going on. Take, for example, a city or a county or a state. As transactions go on sequentially, and this is database theory, transactions update databases, those sequential workflows are integrated into real-time geo integration. And this is just beginning, actually. This idea of faster machines and smarter software has led to lots of transformations. AI, autonomous vehicles, lots of interesting work. And what's emerging, and this is a little visionary, but it's not very visionary, is that geography, location, is becoming a common framework for many of these things to integrate around. So imagine pervasive, real-time geographic information services being available to everyone. And I've thought a lot about this, actually. I mean, you might ask the question, is this really going to happen? Or is this just some, vision, half-assed vision or something? So my sense is that it's not only going to happen, it's not only possible now, given the technology, but I think it's actually inevitable that this geo frame will bring information from many sources together. And what does that mean for assessors? How do you take advantage of this? And my sense is that you need to get your oar in the water and move. You can't be casual about digital transformation. I mean, at my age, man, I am paddling faster and faster because I know if I don't, I start moving back. And this is one of those situations where you need to be all in. And our partnership here with Thomson Reuters has been just remarkable because they are embracing the latest techniques, not just of our firm, but all sorts of interesting software to keep pushing. And I think we can envision better organizations, better society if we are all in on this. And this isn't sort of something where, it's a passive sport. Your work is accelerating with respect to digital transformation. And okay, those of you who are older saying, well, I don't want to do it. Hey, look, if I can do it, you can do it. You've got to leverage computing, leverage AI, leverage all of this infrastructure that's emerging, and just continuously learn, continuously have a vision for creating better organizations and a better future. Well, that's about half of my talk. You okay with it so far? Okay. And it's a bit challenging to you, I know, but it's challenging to all of us. I wanted to spend the second half of my talk about the specifics of the work that my colleagues and I do. About 20 minutes from here in Redlands, we have our main research center. And we have about 1,200 engineers and then all kinds of circles of people that support them who build our fundamental GIS software. And our vision for building that software is to build tools and now services that help our users do their work better. That's sort of the frame that we keep in the back of our head. And then this second last line is, and in the process, address many of the challenges that are facing all of us. So in other words, do your core work, which is really to serve you guys in your work, but then at the same time craft that technology in such a way that it addresses greater contextual problems, environmental problems, land use problems, population problems, all of that. So I'm sharing a little bit about my own philosophy, not because I want to be preachy or anything. It's just for the last 50 years, that's been kind of our frame for doing our work. And in your work, I suspect that you want to make a difference as well, right? I mean, you're doing your normal work, and you also see your own life and your own work in a context of making a difference. And especially those of you in public service, absolutely do this. I'm just sort of sharing my sense of it. Well, now, what we focus around is this little technology called ArcGIS, and I'll go deep on that. This generation of ArcGIS, as I said earlier, is not only a complete mapping and GIS system, it's also entirely services-based. Now that's relatively new. The last few years, it's been kind of inching up, but now we can simply say, you can continue working with your desktop, you can continue working with your server, but the connection between those two worlds is based on a services connection. You can continue serving your data out, but now these services can be taken advantage of in all kinds of web apps and device apps in the field. And those services are also open so that young, creative startup organizations can read those services in and create something beautiful. And also other organizations can use your data as a service. Like in Las Vegas, the city and the water agency out there are using each other's services. They're not sharing data anymore. Isn't that an interesting thing? In other words, if county appraisers serverize their data, and some of you definitely have, other organizations like public works departments can read your services in and do work. So let me just share Los Angeles, okay? I was in the city of Los Angeles Public Works Department about a year and a half ago. I went up to this young engineer, and he was editing this water line. You know what it's like to edit a water line. You add a water main, you add a pipe, you change a pipe, whatever. I couldn't really tell what he was doing, but I knew he was doing something like that. And he had a base map behind the water lines. And I said, gee, that's a parcel base map. And I asked stupidly, is that parcel map coming from the planning department's parcel map, or is it coming from the public works department parcel map? Because there's been a war in LA for the last 50 years. There's the planning parcel map and there's the public works parcel map. The planning parcel map is totally complete, but not very accurate. And the public works department is highly accurate, but not very complete. So it's just been a politic bullshit in a way. He said, no, Jack, I'm not using the planning department, I'm not using the public works department, I'm using the county's map as a base map service. And I said, well, why are you doing that? He says, well, because it's updated 100 times every day. Isn't that cool? I thought you guys would appreciate that story. But apparently not. But it makes the point that we are moving to an age where distributed services are going to be serving, agencies and organizations are going to be serving each other, creating a kind of dial tone infrastructure of geography. And this system is designed to be able to capitalize on that. And many of you I know are our users, so this is what is either being used by you now or coming. And understanding that context is really important. So I would simply say that it's helping you within your own world, like automate field operations and the system of record parcel management and modeling and analytics and visualization, all those things clearly, but also in public engagement. And here I'm not just talking about G2C, your citizens, but also I'm talking about something richer, which is this idea of agencies supporting other agencies. This is in a city, this is in a county, this is in between public and private. This is where I think it's going. And, okay, I'm not totally sure about this, but I would guess that that's going to be increasingly what people demand of public agencies, is that their information isn't just open data. Here's my open data, you figure out what to use it for. Well, that's very popular these days, but I think it's open services so that people can drag and drop and integrate these things. Even amateurs. Like there's a case up in Long Island of open services from EPA about toxic sites, and also open services from CDC about breast cancer. And so some amateurs there started mashing these two things up together, and they made discoveries. It's kind of like amateur astronomy with telescopes. So geography is going to open up, and you're going to be part of that, and people will start to mash up and make things accountable, make them more interesting. So it'll be demanded. I think that's my assertion. It may be long after I'm dead, but that I think is where all the arrows are going. So again, now I will show a few things that my colleagues over there in Redlands are working on. They're largely focused on GIS advancements and also this mapping and location intelligence advancements, which is kind of an easier version of GIS to deal with. Lots of different developments. One of those is a simple concept I want everybody in the room to walk out of here with understanding, and that is that the world of distributed data is growing. How do I bring that data together? In the past, I'd buy a big old Oracle database or SQL Server database of some sort, and I'd shove all that information together, and then I could do work. But today, I can abstract data where it lives, maybe in Australia. I can read the data in as a service and abstract it into a web map. You follow me? I mean, I've said it now 3 times, I'm saying it one more time. This is how it's done. I can take CAMA data, tabular data, and leave it right in the big database that it's in, but I can view it as a map, geocode the data, and view it as a map, relate those relationships to a map, and view it as a web map, a very lightweight little HTML document which is fed by a REST service. So the world is going what they call RESTful, REST services. People are making their content available as services. And this is great news for people in the GIS domain because they can read those services in and dynamically integrate them as if they're in their own DBMS. You follow? Should I go deeper on this? Or do you get this idea? It's a conceptual, really amazing idea because it means the whole web of geographic data out there, pictures, imagery, vector data, 3D maps can be dynamically viewed across the web and integrated into my agency to be able to do analytics or creating new maps. Here's where I'm going back to this creating a common language, a kind of common digital language. And that means very simple things like the integration of maps and GIS and the CAMA land records, permits, and public works don't require hundreds of thousands of dollars of coding and special IT. No, we can integrate them at a higher level with this web services concept, REST web services. That's a big deal. It means integration among distributed systems can happen a lot easier. So GIS integrates with lots of different types of systems. Mapping systems, imagery systems, tabular systems, real-time IoT systems, big data systems. I can bring it together. And I won't have time to get into the specifics of it, but there are thousands of organizations, including America's national security systems, CIA, DIA, NSA, the military, that are all creating satellite pictures, human intelligence, signal. They're bringing it all together this way. In the city of Boston, they're bringing it together this way. In NATO, they're bringing it together this way. In utilities around the world, they're bringing it together this way. So it's a whole new shift in IT, and more specifically, GIT. Now, not only does it come together at the bottom like this, it's like an hourglass because the other side of the hourglass is apps. I can have field apps that can access those distributed sets and mash them up. I can view it in a dashboard. I can make it available to the public. I can tell stories through it. I can republish these data sets and their mashups on social media. And so you see this revolution? Pulling everything in, dynamically integrating it, publishing it out through apps. So the app revolution is key to this new generation of WebGIS. And in the center are tools for smart mapping. I can now display very, very large volumes of data. For example, this one right in the center, New York construction. This is looking at the last 50 years or so of housing construction. In a browser, I'm using, I'll say technical speak here, a WebGL. For some of you that might mean something. Very fast streaming out of a database into a browser or a device of all the buildings that have been built in New York City the last 100 years. Isn't that amazing? This is transformational. The idea that I can have browser side or client side rendering and analytics dynamically. And I can explore this data, drag and drop. This technology also can be fed by something called ArcGIS Online. This is a huge repository of over 16 million data sets and layers for the whole planet, which are being added to daily, thousands every day, of maps and data that are being shared by others. So this is all freely available. You can just go there, pull up a base map, pull up the last Landsat imagery from last night, overlay your data on top of it. I can access demographic variables, like 17,000 demographic variables, and analyze my property in reference to surrounding demographics. So I don't have to collect all the data anymore, that's what I'm saying. Some of it's authoritative source, curated carefully. Others are just thrown in there by other users who want to share their vegetation map or their storm map or like that. Another component that is coming along is apps about the field. These are apps that allow me to support my workforce with management tools that say, you should go there, you should go there, you should go there, you should go there. And little tools for data collection, like feature data collection or tabular survey data collection, and tools for navigating. The US Census Bureau is using a combination of these apps to do the 2020 census, as is the Philippines collecting their census for 2020. And these are simple apps. You know, everybody has apps on their phone now. I can have some location apps that track where I am, tell my boss where I am. Some people don't like that idea. It's called Slacker Tracker or something like that. But you as managers would love that idea. Where are my workforce? I'd like to be able to tell them what to collect and managing them from a dashboard application back in the office, connecting the field workers with the office using geography as the way to carry it out. And these systems now are fed increasingly by imagery, sometimes real-time imagery from drones. Firefighters use this constantly, being able to read in imagery, process it dynamically, and do analytics, things like change analysis or classification or feature extraction. Imagery from drones, imagery from satellite pictures and other sensors. And as I mentioned a second ago, dashboards, these kinds of apps, are very powerful. They allow us to monitor real-time transactions that are occurring in the field. Caltrans here in this state are using it to monitor traffic, and you see it in things like traffic in your little apps. But imagine monitoring all of your field force in real time or other transactions that are occurring in real time, and then in turn publishing that for access by citizens. In the field of analytics, there are over 1,000 spatial analytic tools which look at spatial statistics, things like exploratory Bayesian kriging, for those of you who are in the statistics world, that help us predict and describe phenomena. And this isn't just 2D, they're also in 3D, so I can look at imagery, measure it in 3D, maybe help my assessment as a convenient browser app. And AI, just like it's enriching almost every IT application these days, has also been integrated and embedded into the GIS frame. Machine learning and AI is a kind of separation of things that deal with simple statistical analysis, or not so simple, but allows us to geoprocess and come up with formulas that we can feed over to the AI environment to make long-term predictions and descriptions. So we support now all the modern platforms and also all the AI frameworks to help do that. And I know some of you are very engaged in this. You can ask some of my colleagues about this after the meeting. 3D is very important, both in visualization and analytics. And finally, I'll simply say configurations are important. Now, we have about 350,000 organizations that we support with these tools. Everything from, my friend says, from fries to spies. In other words, from McDonald's to CIA. Okay, that's a bad joke. But anyway, all kinds of different organizations and types who have geospatial problems. And so it's a generic platform. But more recently, we've put about 70 people on building simple configurations and apps for our users. These are all open sourced and they're free. And these apps and configurations are particularly focused on local government and utilities, but also some in your area dealing with property configuration. You can go to the website, they're in GitHub, you download them, and you can configure them around your system. Some of the generic ones are ones that allow dashboard reporting of assessments, or 3D viewshed analysis when we're looking at appraisals, or communication through story maps or analytics. These are some more that actually represent the specific assessment apps. Part of it is address management, but certainly a big one is being able to do things like photo surveys or crowdsourcing or parcel viewing or comparable sales finders. These are browser-based apps that I can simply configure on top of my standard application, and then they're free. And you can sort of load and go. The last one I want to talk about is one of my favorite, and it's about community engagement. How many of you are from California? About 18%. No, okay, about 20%. Some of you will know a mayor here in Los Angeles called Garcetti. He's an amazing guy. When he took office, he began to get involved in GIS heavily. And one of his visions was, how can I leverage all the information that the city of Los Angeles spends on GIS to be able to connect my community? Kind of a real citizen engagement. So we've been working with him on something called a community hub. This is based on initiatives. So most mayors, most managers, most elected officials like to initiate things around policies, big ideas like traffic or homelessness or too high a taxes or whatever it is. And he globbed onto this idea that he'd like to create map-based initiatives that he could interact with his community and get feedback. Because really what every citizen wants is more information about their community, or at least a lot of them do. And what the leader wants is feedback from their community about a particular initiative like traffic or whatever it is. So we have configured now a technology which drops on top of our standard GIS, which does this. It's called the Hub. And it supports open data and open services, but more importantly, it allows us to organize these initiatives, allows the government to organize the initiatives, and then engage with citizens through a portal. Again, maybe you guys are not so interested in this. I'm terribly interested in this because it's leveraging the geographic data that we spend a lot of money on to be able to get citizens participating more directly and enthusiastically in government. I've talked a lot about technology, maybe not enough for some of you and too much for others. I've tried to share where the technology is going. This is a new generation that we're in. But being able to implement these systems, my experience is, requires a lot more than technology. It really requires vision and leadership by executives and involvement by executives. This isn't sort of like, okay, Johnny, okay, Mary, you take this and do it. I think it requires deep interest and involvement by executives to make it come alive. It requires somebody to be a strong champion. That's both a leader and a technical assistant, a kind of team of two. That's my experience. And they need to understand the full mission of whatever the agency is up to, and then understand how geography can matter, understand how it delivers value, what's the cost benefit of it, and then envision an architecture for realizing it. And some of these systems are not sort of like I buy something and then implement it. They require months and years to actually integrate and make come real. That requires executive support. And then when it's done, it requires ongoing governance and evolution. And finally, something that you guys will probably recognize more than ever, good people to be able to pull this off. And I like this idea of good people. We need to just hire good people. Actually, early in my career, I realized it's not about hiring good people, it's about creating good people. Creating a culture where goodness shows up, because I believe that most people are really good by nature, and given the right challenges, given the right context, they want to do good. They want to be team players. They want to make a difference with their lives. So I put that in there, good people, because I wanted to make that point. Creating, as many of you are managers in these organizations, creating the right spirit, the right kind of culture of collaboration and doing good is important. Chris Thomson once said this, this is not of Thomson Reuters, Chris is a different person, but once he said this idea of collaboration moves at the speed of trust. So inside of organizations, being able to pull off GIS at scale really requires this culture of trusting. Trusting your employees, trusting your bosses, creating that sense of sense of unity that geography kind of brings out in a way that allows us to really move forward. Well, I'm going to stop here. I've covered a lot of ground. Maybe some food for thought as you go through the rest of your meetings here. And I appreciate very much the chance to speak with you. I'll stop here. Thank you.